All right. Good afternoon. My name is Casper de Jonge. I'm a principal program manager in the Power BI team.
I'm David Maga. I'm a senior program manager in the Power BI team.
Today we're going to talk about debugging Power BI premium performance issues. So we're going to look at a few things. We're going to take a look into, okay, how can you identify what is going on in your premium capacities? And we're going to take a look at a few cases, some very common cases. Like we're going to take a look into, okay, first of all, we're going to talk about, okay, when and why performance matters. Like, why is it important in the Power BI world? Then we're going to take a look into what the role is that Power BI Premium plays. Then we're going to take a look at a few concepts, like identifying data refresh issues, because that's pretty common in the Power BI Premium case. We're going to identify some slow reports. And once we've identified those, we're going to take a look into, okay, so now we know which data set is problematic. How can we tune that? How can we figure out, okay, this data set is problematic, it's slow, there are things going on. How can we make it faster, and how can we identify these things? David?
So all of the techniques we're going to kind of highlight in this session are illustrated in textual and visual form in a white paper we put out around February. It's called the Premium Deployment White Paper. So if you think you need to revisit those, it's a good read. There's a chapter there about exploring real-life scenarios. And those are the real-life scenarios we're going to talk about today, basically. So take away.
So I think the most important thing is why are we here? Why are we even talking about this? So performance is always important in BI tools. And there's a few things, because performance of Power BI is always related to two things. Analytics, people looking at reports, they want to interact with it, they want to see the reports, they want to click around, they want it at the speed of thought, they want to be fast. But they also want the data to be up to date immediately. So even though it's maybe not realistic, they want data always to be up to date as much as they can, as fast as they can, no matter when and where, no matter how much capacity you have, they still want it. So based on those things, that many factors go into this from an individual report and modeling design to manage these premium capacities. So instant data and analytics and refresh is really why performance matters, because that is what we see every day.
So Power BI Premium is different from the standard Power BI Pro license, where in the Pro license, there's a shared capacity that we manage. In the Premium capacity, you have more power and more features and a dedicated set of resources, but basically it comes with responsibility, and that responsibility is that you need to manage it. The next slide so the next slide is kind of a summary that we showed in previous sessions as well about all of the great pillars that Premium gives you. It gives you flexibility of licensing, distributing it across your org for free, greater scale and greater performance in almost any piece of content that you can generate. We have a new types of content that are available only in Premium, like paginated reports. And we even package a license for PBI Report Server, which extends you the on-premises capabilities. But one of the things that are missing when we talk about this thing is that this comes with a dedicated resource that you not just can manage, you should manage it, because otherwise these will stop doing what they're supposed to do, which is work fast, as Casper.
So maybe we can ask a quick question. Who here manages premium capacities? Okay, good.
Great.
So one of the problems that we do see sometimes in cases is that people buy premium capacities because they are not buying licenses for everyone in the organization. This is what premium is for. But then they're not actually looking into the metrics. They're not actually managing the premium capacity. And of course, the downside of premium capacity is, and also the upside, is you buying capacity to handle the load.
Yep.
And if you just load it full with data sets, and if you just let all the users go out and play with it, you're going to run out of capacity. So sometimes we get calls and saying your product is very slow. What's going on? And then he said, well, have you looked at the Premium Capacity Metrics app, which we'll talk about in a second? And he said, what? And then, then we're back to square one. So this is the interesting benefit. Like if you buy Power BI Pro license for everyone, that's the shared capacity that David was talking about, we'll manage it. And we'll just spin up as many nodes under the covers as you need. But if you get premium capacity, then we won't. Then it's up to you to figure out how much load can I add to it. Which is also a benefit, because sometimes you're okay with refreshes being slow, sometimes you're okay with the queries being less fast, but because you pay less. I mean, it's all about scaling. So that's why we said you should manage the premium capacity.
But you're a great audience, so great. So what does the admin need to do? You are responsible basically on how much load you approve. There's no like workflow that you approve each thing to go or not go on the capacity. But if you want kind of engage yourself with the metrics app and understand and look for problems, you're getting risk of the following cases. Bad report performance, which will be generated because queries will wait for other queries to end. Queries will take longer to finish because they don't have enough memory, and so they'll wait their memory available for operations as a scratchpad to perform the calculations would be less and less, and that may make them less efficient and will just take longer. Data sets may go in and out of memory kind of sporadically and in high frequency. Each time they go in and out of memory in high frequency, it means that we need to get them back to disk, load something else from disk. Sometimes we have a bad eviction where we import back into memory something we evicted a minute ago, and we actually measure these in the product side, and that's basically inefficient because we wasted time on reading and loading stuff we shouldn't have evicted. All of these will eventually, degrade your performance of the report and the queries. In rare cases, you might even get out-of-memory errors, and while you're actually viewing the report and trying to render a query, that's in cases of extreme memory pressure. Refreshes are also subject to your management. If you won't manage it properly, then data and reports will be stale because refresh will either start later than they should be. They might take longer because under extreme memory pressure, we will pause refreshes, let the rendering traffic kind of come in and be served properly because rendering takes priority over anything else. And then the refreshes will restart again, and that is again inefficient, and eventually might cause the CFO to kind of try and watch a report, and the report is and then the data from yesterday because it still haven't got to the refresh. Not this one. And even on-demand refreshes are subject to the same conditions where they might pause themselves and they might wait for the refresh to start. So that wouldn't save you as well. So again, you have to manage it. In rare cases, the capacity itself may hang because you had too much bad queries going and too much memory was kind of utilized for them. That's the reason we built a restart button into the advanced option in the premium capacity settings in the admin portal. So it's not common that you need to use it, but in case you get to it because a lot of bad content was uploaded to your premium capacity, there is a self-service way to resolve it. It's not a destructive event. It doesn't destroy any report. It just flushes the memory and let everything kind of trickle in again. So FYI.
But I think also the interesting question is when you're managing these capacities, it is up to you to kind of decide how much am I okay with. Like, I can have optimized for the best performance. I can optimize for my data refresh to happen instantaneously, or I can be okay with a little bit of wait time. Like, I'm okay with my refreshes taking a few minutes after that it originally was scheduled because it's too busy. Because there's a few ways to optimize, of course, and we'll talk more about these, but optimizing the models itself, but also, like, of course, buying more capacity. And that is, of course, always return on investment question that you have to answer. So it's always good to think about when you're managing these capacities, what am I okay with? And those are the thresholds that you should look into when you're managing the capacity, which we're going to look into now.
So what we introduced in previous sessions is something we call the circle of life, which is the kind of the paradigm we want capacity administrators to constantly engage with. It means you need to evaluate the load that you want to run in your capacity and with that fit in your capacity. You need to monitor in yellow, which is a bad choice of colors. Oh, that finishes up here. Which is using the metrics app. We'll see some examples of how to monitor for specific phenomena. You need to constantly promote in your organization, the adaptation of content to be more performant. There are a number of very good sessions that were delivered earlier today and yesterday about optimizing content, the do's and don'ts of data modeling. We'll touch on a few of these here. There was an earlier session by Bavik, which was a shopping list of like do's and don'ts in report building. So that's a constant chase right now between administrators and managers of capacities and content creators, because the content creators just want something beautiful and want to share it with everybody because it's beautiful, and they don't really care about how much load it's generating, and it's up to the capacity administrators to kind of make sure that everything fits. So that is adapt in the circle, and eventually there's prevention, which is the tool set that you, the administrator, have, where you can set some settings on the premium capacity that will prevent certain phenomena from having too much of a serious effect. You can prevent the content uploaders from uploading bad reports with bad expressions, but you can prevent the effects that these uploads may have on your capacity. So let's, we call out the specific sessions that, because you have the material available for you online, you can go after this session and at home kind of review the decks for these material and understand more about adaptation and dive deeper into evaluation and prevention as well. So because how many people here attended yesterday's workshop or earlier today's talk about premium? Okay, so the majority didn't. So this is the metrics app, and I just want to show you, like, introduce everybody. You're managing it already, so you're a great audience, but most people, like in rare cases, people did not know about it. So let's see the next slide. So now we're going to walk through like cases of capacity admin from the IT department and the CFO from the CFO department. And we're going to do a game where I have problems and Casper is debugging them. Oh, Casper has problems, I'm debugging.
Exactly.
Okay, sorry. Casper.
So no, I think in this case, like this is one that we will see a lot, and especially now with the new UI that you've seen as well in Power BI and at the keynote, we'll actually show you in the reports when it was last refreshed, and when they would expect refresh to happen, and when it actually happens could be different because of the load that is on your premium capacity. So in this case, like it was scheduled to be done every morning at 9, but the CFO was looking at it at 10 and the report still wasn't refreshed. So next day, same time, nothing happened. So the user again says, okay, my data is not up to date. My data from yesterday is not up to date. What's going on?
So I'm the poor guy in the IT department that needs to figure out what's going on. What I do is click next slide, next slide, next slide, next slide, next.
Yeah.
Another one. Okay, so we need to find refresh issues in the capacity metrics app. So a quick introduction, you might be familiar with it already. The metrics app has tabs per workload, and in each tab there's a number of pages related to the metrics that you should be mindful of regarding that workload. The most important workload is, because of popularity, Power BI reports, it's called datasets. Other workloads have different pages, so this is the datasets tab. Within the datasets tab, there is a refreshes page. That's the upper right leftmost button. The refresh page looks something like this. Next click. You see a summary of the duration and the wait times in tabular visual for all the refreshes. And you see this nice little chart of aggregations of wait times and an hourly refresh count and memory consumption superimposed on one another. What we look for to solve common stale data scenarios is patterns of periodic spikes in wait times. In an actual case that we got once, could you click? Thank you. It looks something like this. So the scale of the bars it can vary, but we saw cases of like periodic mountains, sometimes 35, 45 minutes long. And that will cause a report that was scheduled for 8:30 a.m. because somebody wanted it at 9 a.m. to start refresh at 9:10 a.m. and they get to their office and the report is yesterday's data.
So I think, again, maybe it's important to recognize, like the average wait time means This is the time that it's waiting between the scheduled time and when it actually starts.
Just
So-
starting, not duration. Yeah.
Exactly.
If the refresh itself takes another 15 minutes.
And the reason
or
why
20
it's waiting is that there is something going on in the capacity. Because if everything would be okay, it would start on time. But now we find out there is something happening here, and we need to go figure out what's going on.
So this is the technique that you can, the technique that you could take advantage of right now to identify kind of refresh staggering schedules, where too many people scheduled refreshes at 8 a.m., for example, and why doesn't all refreshes take place at 8 a.m. It also highlights point in times where there's too much ongoing rendering traffic that doesn't allow the refresh traffic to actually commence. So if everybody, if refreshes are scheduled for 9 a.m., for example, and that's where everybody look at their own reports in your organization, refreshes won't start at 9 a.m. Now, in the current version of the metrics app, we group these two together with just reporting the wait times. In upcoming versions of the metrics app, we're going to actually separate the reason for wait times. Was it because there was too much ongoing traffic? Was it because there was too much scheduling over that specific time slot? And you will be able to follow up on it a lot faster than you do right now. So once you identify this today, in order to actually follow up on it, you need to do the following. Click the next slide. Let's say periodic spikes. You need to find the workspace owner by going to the capacity settings page in the admin portal. Email the workspace owner to find the dataset owner that had the high memory spikes. And that dataset owner needs to change the schedule or do something about the refresher that we recommend in a second. Right? We understand that's not the simplest or the easiest flow to follow. So we will build an ability to identify dataset owner from the report. It will show up even soon, but not immediately. So it's important to highlight how to do it now and how simpler it will become eventually. Now, how do you fix the too many refreshes waiting problems? There's a number of strategies. The first one, just stagger the refreshes evenly across your capacity.
Isn't the wait time staggering it for me?
Sorry?
Isn't the wait time staggering it for me?
Stagger the schedules.
Isn't the wait time staggering the start times?
It is, but not the way
Maybe
you want it.
I'm abusing the word stagger. Okay, okay, so spread, the word stagger was incorrect. Spread your schedules evenly across the capacity so that you're not staggering them, you're right. And when you do it evenly enough, then the periodic spikes would not happen because the schedule won't trigger all at the same time. The second approach is make refreshes take less time. Now, there's a number of tools that will allow you to make refreshes take less time. The first one is incremental refresh. Incremental refresh refreshes using only the new data that is not in the model yet. It takes a lot less memory, and it's faster to complete because of that. You need to configure it properly in the dataset settings tab for that specific dataset. So it's the dataset owner that needs to configure it. But if all your dataset owners will do it, and we recommend any refresh for that takes more than 20 minutes, do it, because it's just otherwise ineffective, then refreshes will be more efficient and will cause less wait times for other refreshes on your capacity. Using aggregations is a technique to report really large data sets based on associating with a Spark cluster, and it's quite complex, but it's preventing the need to refresh large data sets, and therefore preventing other refreshes from not being able to use the capacity because other refreshes are running. So that's about making refreshes take less time. Fewer data sets. We recently, about a month ago, shared and promoted data sets on the capacity. A very common scenario that happens, especially in the self-service world, is somebody builds a great report, somebody seeing that great report and builds another report based on that great report, and now you have two versions that were actually the same report, but they're different file names and that were published by different people. And those generate two different data sets on your capacity that get loaded in the same time, each with its own refresh schedule, and it's just inefficient. By using shared data sets, you're basically preventing that phenomena from happening and make sure that there's only one version that needs to be updated. Query folding, you want to talk about
Query
this?
folding, yeah, I think one of the big techniques, just like AGS, is because in these cases, query folding will allow you to use the query patterns inside of, well, when you import data and you refresh data, the most important thing is whenever we can push data down into the underlying SQL Server database, like let's say, for example, you do an uppercase and a left case in your Power Query when you import data, and when you can do query folding, then it's going to actually ask the SQL Server to do those operations instead of Power BI having to do those operations. And when the SQL Server does the operations, then Power BI is not working, SQL Server is working. And the way you can see this is by, if you, in your Power Query, the last step in your Power Query steps, you see the view native queries, a bit small here on the bottom, but if you see the view native queries here, and you can click on it, you can actually see the SQL query that's being sent. And if that is enabled, then query folding works. If it's not enabled, it doesn't work. And there are cases that it doesn't work, like for example, if you connect to a data lake or a blob storage or CSV file, because you cannot ask a CSV file to do uppercase or joins or whatever it is because it doesn't know what to do. SQL Server does. So query folding will definitely help you with those scenarios.
So another important note about query folding is that refreshes are divided into data read time and processing time of the actual new calculated tables and all that. What query folding does is allows you to test basically having the processing time shorter on the Power BI side and having some contribution to the data bringing time from the SQL Server. If your SQL Server is capable enough, it would be benefit. It might not, so not a guarantee, but it is. And we have more improvements coming up that we show in some videos. Another click. So, as I said before, we're going to make it simple to call out the exact reason for refresh wait times. There's two more bullets. The dataset owner will be identifiable from the report, and okay, so I think one of the best improvements we're planning to deliver on this space is to show the capacity managers not just where queries are waiting, but kind of consider where refreshes are waiting, but kind of consider the refresh durations that are happening in every time slot. That would give you the ability to identify where you are over budgeted in terms of your refreshes in timelines and where you're under budgeted. So you will also know when to recommend users to move the refreshes to, because that time slot was less utilized. So that's about, any questions about refreshes optimization?
So when you press on view native query, sometimes it says it can't determine and it works, and other times it says it can't determine and it doesn't work. If it works, should it always show you the native query? Or
As far as I understand, it should always show you the native query that is going to send.
It should be faster, basically.
No, I mean, if you click on it and it doesn't show you, then there's no query folding.
Oh, you mean
it should be grayed out.
in the UX itself?
so it performs faster, it just finishes in minutes, but then it says it can't confirm that query folding could happen.
When you set up refresh? Or when you click on that?
When you click on that.
So what we know is if you're able to see the query in native SQL, it is better to offload the heavy processing there. Right?
Does that only work with SQL Server?
It doesn't only work with SQL Server. It works with multiple different data sources, but again, the way that the engine is trying to determine if it can, and if it does, then but sometimes it's not able to determine if it actually works.
It's a Power Query feature. They keep updating it, so when we could channel through the questions. But
no, but it's not. So it's not just SQL Server. It's also other data sources.
Yes, please.
Is capacity affected by the number of end users using the dashboard itself or the reports, or is it just by the report?
It's depending on the data model. So basically, data models.
No, it's So it's always affected because people send in queries, and we'll look at the example next because we talk about data refresh, we'll talk about queries as well.
But it's a dashboard, not
But
reports.
even like when people look at reports, it sends queries, and that is everything you do on the capacity has an effect. And it all takes away from everything that is shared because refreshes, queries, anything you do on the like paginated reports, data flows, everything eats away from the same memory and CPU that you have available.
So when the capacities render a report, they process queries. The more people send rendering reports, the more queries are processed.
Yeah.
Other artifacts in Power BI can use cache queries like dashboard, and when you said dashboard, I was referring to that. Dashboards can use cache results of queries. So when more people view the dashboard, like the actual pin tile KPI dashboard, it doesn't generate any load, just like page render, right?
Except when it refreshes.
Except when it refreshes, and we'll touch that in the other slide. Okay.
All right. So in this case, and now we've seen refreshes, so now we're going to talk about data sets being slow all of a sudden, right? So the CFO is looking at this report. Last week was fast. This week, not so much. So what's going on? It was fast before.
So, the capacity metrics app. This is a screenshot of the query area, of the query page of the metrics app in the dataset tab as well. The query durations and query wait times will be where we're going to focus kind of our investigation in these cases. Query durations show you a histogram or breakdown of the entire aggregations for the entire time span of performance of queries. A quick top 5 query duration datasets, and a tabular visual that maps out all the workspaces and datasets and their average and max query duration. What we look for in a report that is, was okay one day or 1 hour and not okay the second hour, it's kind of outliers and the patterns that we see on these histograms on an hourly analysis. So we built the histograms using colors, right, to kind of highlight different performance groups. And we found that when you look at a certain traffic pattern of certain reports, it tends to be consistent based on the report if that report lives on its own. Consistency meaning the formation of the color scheme is kind of the same. In this report, we always see like a good chunk of blue in the middle, followed by a black, red, a bit of yellow on the top, and that's about it usually. But if you look at the outliers, there are outliers where the blue disappears, or the light blue shows up and the orange and the purple show up on the top, right? That's what we call outliers in the patterns of histogram. Sometimes it's minor, where you see like a bit of light blue or pinkish areas, and sometimes it's really obvious, where you all of a sudden see like a huge chunk of turquoise or something like that. When this happens, it's usually because one report interfered with the other's ability to, or the capacity's ability to render the queries from another report. So the technique we're going to use basically, could you next slide? Outlier graduations. We're going to cross-filter one such outlier column, and that's going to show us in the top query durations visual, the table, right? It's going to show us all of the data sets that were hitting the capacity in that hour and caused basically that histogram. And once we highlight those data sets, we're going to look for the longest running queries that the capacity may have been occupied with rendering. And the rule of thumb in this case is, the longest running queries were the one disturbing the most for other data sets to run queries against, right? So we want to handle the longest running queries and data sets that were causing the longest running queries and make sure they don't take that long. And soon Casper will show us how to do that, right? Mm-hmm. So we have like the 3 steps listed out in the bullet, right? Cross filter on the outlier bar, identify data set with longest running queries, and then likely this data set is the noisy neighbor that's slowing down other data sets.
So there are 2 things here, right? You can see not just the duration, but also the total count. And the total count means how many queries are being sent. Yeah. So usually it's a combination of the 2. When you have lots of visuals, and we'll talk more about this in a second, when you have lots of visuals on your reports, all of these like work against each other because every query needs to be sent and yeah.
So this is a fairly kind of complex flow. Are there any questions about it, or is it clear out of the box?
Where does the data reside, and is it available for us to download?
So the aggregated data, the underlying data for these visuals is available there's an Analyze in Excel button on the top right corner basically of the report. That will give you the aggregated results in an Excel sheet that you can do whatever you want with. In the future, we will expose the actual data for you kind of to
Now, if you have an Office 365 admin, you can actually go and get the logs and get the
But
data as an aggregate.
what you get in the Office 365 are audit logs. Audit logs are not performance traces, so they don't have the richness that these aggregates were based on. We have seen solutions that enterprises did where they use the Analyze in Excel snapshots, right? And they cross that with a dataset name and workspace name that they parsed from the audit logs, eventually creating their own reports that associate a dataset and consumption together. It will still not allow to say who viewed the queries that took the longest. It will just tell you who viewed that report, and you could identify basically the department or the set of users that may have caused that traffic. Yeah. So, which company are you working for? Okay, so I'm interested in hearing that. But another question?
So is Power BI data flows, the performance of that part of this metric report?
Yeah, it's part of a different tab. We don't see yet many cases of noisy neighbors in data flows. Actually, the way that data flows work is different than the way analysis services dataset works. And so the phenomena are different. But there's a dedicated tab for data flow. We just don't have time to review like similar cases for data flows. But the metrics for data flows are there. Yes?
With the Power BI report, is it relevant to the type of connection, if it's a direct query or import?
It's very relevant. The metrics show or doesn't show up based on the data source. For example, Live Connect data sources, where you connect to analysis services elsewhere, don't have any recording in these tabs because the processing is done elsewhere. Direct query is a realm of its own. Its phenomena look different. This analysis was based on import mode. In direct query, the limits are also different. There's a throttle about how many queries you can send downstream. In a second.
I mean, you can definitely see, like, when you use direct query mode, for example, and you haven't optimized the database or things like this, the query times potentially can take longer. It doesn't have to be this way. So again, yeah, it makes a difference, but you can optimize it, and we talked about before, like if you use aggregations or things like this. So it makes a difference, but it can work in either case. So it's not really said to say direct query is always worse than import, although often it is, but it depends on how you optimize it.
I'll say it differently. Queries that need direct query, and then to process in the analysis services engine in Power BI, will still see query duration that is very, very long, right? Because the query takes a long time. You need to fetch the data. The visual query, the query to render visuals in the reports, you need to fetch the data, and that takes some time for the SQL server to bring you the query for that query. And then you need to read it, and then you need to process it in the service, and those will be longer running queries. So, I mean, in that regard, yes, it has the same effect where direct query reports can be more susceptible to creating noisy neighbor kind of phenomena because they take longer time to execute. That makes sense? And there was another question right in front of you.
So for composite models, would we only see the import activity here?
In the query durations?
Yes.
Import.
No, you'll see both.
You see both, yeah. You see
The
both.
only thing missing is Live Connect, and we're
Yeah, Live Connect.
actually fixing that.
So Live Connect has the metrics elsewhere. Composite models still execute queries in analysis services, and those are the queries that are reported here. It's the same answer I just gave basically applies.
Yeah.
That make sense? Okay.
All right.
Now, the nice thing about noisy neighbor phenomena is that they're not necessarily, you need to have a very keen kind of eye for colors to identify the outliers. They also contribute to query wait times. And that contribution is sometimes much more easy to detect than identifying the change of patterns in colors. I think there's if you click next, you'll find. So what we use as a rule of thumb when we analyze capacities kind of on the server side is when wait times are numerous in terms of like the percentage they take from the total queries that hit the capacity. For example, if you have 15% of the queries wait or 10% of the queries wait, that's substantial, especially if the wait times on average of these queries who wait become something like 100 milliseconds. That is really substantial. Often it will be just a millisecond or two, and that's okay, and that's by design. It's nothing to cause an alarm. But when it gets to like hundreds of milliseconds, that's probably having a negative effect that you don't want to see there. And the queries that show wait times the data sets that show wait times are data sets that when people queried for, the capacity was too occupied with rendering reports. This is why the query is waited. So by finding the vertical bars that have the highest wait times, and then looking at the query durations at the same times of the vertical bars, you know that these are times where too many queries were hitting the traffic and a lot of wait times was recorded. And these are the times where, again, the most frequent data set with the highest query durations are likely the culprits to contribute to these wait times. That makes sense?
Right.
Right? Okay. Now, okay. A technique that we use internally for identifying noisy neighbors is to look at patterns of wait times versus patterns of query durations. If the patterns of wait times are are comparable to the patterns of query durations for a certain data set, that means that the data set itself is causing wait times for itself. If the patterns of wait times for a certain data set is not aligned with the patterns of queries for the certain data set, that means that something else is generating wait times for that specific data set. Think about it as we report the metrics are based on data sets and based on queries. We do not report them based on reports. We will update that eventually, but right now we don't. If you have a single report in import mode that has 100 visuals, and they're all coming in a P1, for example, at once, nothing you will do will make the P1 serve all the 100 requests at once. Some queries will wait. But the patterns of the wait times for that 100 visual reports will, there will be wait times every time somebody's watching the report. So the patterns will be perfectly aligned. When you see reports that don't have this alignment, that means something else is contributing to the waits. So this is a detective game that you need to play with the metrics app to properly identify, but it's a very effective way to kind of highlight in an immediate comparison like what's really going on. Is it that report that was just built poorly, or it is just too much things going on in my capacity? I need to start thinking about better load management. Is that slide understandable? Can you take it home and kind of work with it? That's great. Compare the shapes is like, I think that's the best bullet. So how do you solve noisy neighbors? First, I think the easiest solution, buy more capacity, right? Just do it. Another solution that may not work for everybody is that you find the noisy neighbor data set, the one with the top queries, just move it to a shared capacity where we have to pay for the thing that's running it. But then you might not be able to share it across your organization. Only free licensed users can't use it. So that also has limitations. If you have another capacity, maybe you can isolate it and put it on that capacity. If that's busy, that's always effective. The third and the most important thing, optimize the report, optimize the data model. How do you optimize? we talked about it in the previous session, and we'll show some optimization techniques soon. Save queries. Save queries as often as you can. Caching save queries. If you don't need to run the queries, then somebody else could use the CPU. There's a dataset property we released a few weeks ago that the dataset owners can choose to enable. It's off by default right now, and that is called query caching. It basically caches all of the query results for the first page of a report. That means if I have, unless I have row-level security where the queries are different for each person, anybody hitting the same report until the data is refreshed would not generate a query until they actually dive deep into the report, create slices, or actually do something with it. At that point, caching won't help anymore. But at least the first view, that's for free. Another caching that is always there is dashboards. As I said, dashboards are cached query results that are executed when the dataset is being refreshed, and not when the dataset, not when the dashboard is requested to be rendered or shown on screen. When I think dashboard, I'm talking about pinning KPIs in the UX and not report dashboard, because people often build reports and call them dashboards because they are dashboards. So that's the nuance. If you pin the live tile dashboard, it's actually pinning a report in the tile. There's no caching there. That actually complicates things. So a nuance, but an important nuance.
Is there a downside to turning on caching?
If you have row-level security, you may not want it because the row-level security. Other than that, I can't think about anything. Can you think?
Well, the reason you wouldn't want it for row-level security sometimes is it generates too many queries.
Uh,
You might actually put more load on it.
Row-level security datasets that are getting tiles pinned will create more queries that take place right after the refresh to complete the tile updates, and that may lengthen the duration of the refresh because of that. That's the accurate way of saying what Josh just said. Okay. So that last bullet. The last bullet is the best practice we showed in the session earlier today. When in the self-service world, it's very easy for users to make mistakes in modeling and report design and generate too much load that will disturb the report that the CFO needs to look at. Having two capacities and creating one developer capacity that is kind of anybody can hit, but there's somebody looking at the metrics for and approves what get to eventually migrate to a production capacity, which is the only capacity the CFOs are hitting, right? Is a very good best practice that will isolate self-service from centralized BI cases and will prevent kind of what the heck this report is not rendering when it should at 9 a.m. on the executive board meeting and what the heck. So we have a demonstration of an illustration of a flow in the previous session that we had today, 2046, that actually shows that how to perform this separation of duties between self-service and centralized. Now, other workloads can interfere with the dataset workload, available memory, and available CPU. It could be that somebody is running 7 simultaneous data flows at the same time, and that takes a lot of CPU or some CPU from the capacity, and that slows down queries. What we did when we enabled all of the new workloads like paginated reports and data flows is we limit the amount of CPU they can steal, quote unquote. So rendering traffic still get the lion's share of the CPU no matter what, but it could get slightly less because data flows are running. And that may contribute to slower queries and slower durations and eventually noisy neighbors. So look at that as well. And last but not least, if you remember the circle of life, it had prevent. Prevention is your ability to have a few settings that will prevent one person doing bad things from affecting anybody else. We're releasing very soon a bunch of settings in the settings, in capacity settings page in the admin portal that will allow you to tweak the number of rows, for example, that a query can return. It will prevent basically runaway queries from having too much of a serious effect, but they will still have their effect. Like they will still consume memory, it will just affect less the entire capacity. Another setting we will enable soon is called
Right now there is a memory limit,
Right now, the only thing you get there is memory limits, and that's essentially just helping you with memory load and memory pressure, not necessarily with query traffic.
We left it at 20%. Is that optimal?
So the default values is what we recommend you leave them. If you need the other workloads, if you don't need them, turn them off. They take resources. Like you're better off like not taking those resources. I mean, sorry, when the workloads are not running, they don't take resources for anything. But if you are too afraid of them running and taking a portion of the CPU, albeit a small portion, then turn them off, right? So that's it. So third case is just as my data set is low. A very common scenario that we see is that self-service users build a beautiful report on Power BI desktop. It works on their desktop. It's great. They publish it to the app. They share it with the whole department. The department has 200 people, and 200 people hit the report, and it's really, really slow from day one. So how to identify these cases as an admin and what to do about it. So now here's one of the trickiest parts of the fact that we have the data set and query level metrics and not report level metrics. In a slow report, you usually have a lot of slow queries because there were poor modeling decisions made. Those are getting highlighted very easily if you just sort by average iterations and look for outliers. Anything beyond 1,000 milliseconds is what we define as suboptimal because it doesn't feel snappy to the end user using it. So any report that has an average duration of more than a second is kind of not content you want to have on your capacity. The thing is, if I had a really high number of visuals, like 100 visuals on one report, then the visuals, which is each visual equates to a query, might have fast-running queries, but the report will still be slow, and that actually requires some more drill down to understand. But other than that, it's pretty straightforward. Okay, so we talked about caching already. I don't need to add this. Now, it's a great factor that also Babak mentioned earlier today. Minimize the amount of queries used. Less queries is less visuals, and that's more efficient because there's less load, larger capacity, which is always helpful when you have multiple queries coming in at one time. Okay, let's go to optimizing the model. So the most important thing to optimizing a slow report is to optimize the model and the DAX expressions in it. I think that's the part when Casper gets not too sure how to do it, right?
So I think like once you figured out what the problem is, which data set is the problem, there are some techniques that allow you to say, okay, we have this data set, how can I figure out what is taking up all the time and how can I optimize these things? So there's a few things you can do. First of all, Power BI Desktop allows you to connect to an internal port. There's an analysis service engine running on your machine. You used to have to need this. You can use Profiler to do it, but we just released Power BI Desktop's performance analyzer, which I'll show you in a second. This actually allows you to see how long queries take, where is the time spent in my report. And then you can fine-tune it using DAX Studio, and I'll show you this in a second. But it's an iterative process. Like, I think you can probably spend all your life optimizing one report because you can go on and on and on, optimize. At one point, it's just good enough. So, but measuring queries, find the measures responsible for the load, fix it, rinse and repeat until you're satisfied. That's really the structure. So let's take a quick look at the demo of how can we figure out what the slowest query is and what are the slow queries and how can we optimize them. So what I have here is a Power BI desktop file. And when if I go in here and I go to my page, you will see everything takes a long time. Like it's loading and it's loading and it's loading and it's loading and it's loading. How can we now figure out how much time is actually spent where and which are actually the ones that are causing all the issues? And how can we go optimize them? In this case, I took a lot of bad examples and actually managed them to show it. So what I can do is I can go into View, I can go into Performance Analyzer, and now we have this new tab. This is in the latest version of Power BI Desktop. This is turned on. Performance Analyzer, and what I can do is here is I can do Start Recording. And when I do Start Recording, everything that I do in my page, it actually shows you how long it takes. And I can actually go in here and it says refresh my visuals. So when I click this button, the page is going to get loaded again. You can see everything is starting to get loaded. And here we see times added, durations on the right-hand side. So how can we figure out what is slow? Well, first of all, you can see one big table here that is really slow. If I click on this, you immediately see the highlighted visual that it was slow, but you can also see what is taken up all the time. And you can see here the DAX query takes up a lot of time, but there's also other stuff. The visual display, so maybe you have a visual that has a lot of data points or things like this, then the visual display would take a lot, and actually DAX is not taking up a lot of time. If you have a very complicated visual that you want to show, a lot of different things, then this would take up a lot of time.
Third-party visuals are notorious in that.
Third-party visuals could be playing a factor in here, but not always. But yeah, so that could be. Other is also there's lots of other things, because maybe we're waiting on other visuals to finish and things like this. But most important thing is DAX queries. Yeah, question?
I just wanted to ask, you mentioned third-party visuals, including the certified third-party visuals?
Yeah, I mean,
Yeah, they could.
including certified. Certified doesn't mean the code is great, but if you need to draw a lot of stuff, then you need to draw a lot of stuff. Like if you must have it, do it. But I'm just saying,
some
people
of the-
don't think about it when they design.
Some of the visuals can go completely crazy on what they want to draw and how they want to draw it. So it doesn't necessarily have to mean like the visual is bad. It's just like it just takes time because I'm rendering a lot of things. And actually, you can see it happening right now because my internet connection is not great. I have a map visual on the left, bottom and right, and it's still running.
The pattern of slow reports is that, as I said it earlier, like it's usually people building beautiful reports and don't think about scale. And this highlights that beautiful has a trade-off.
So you can see all of these things, they just add up, right? So you see here on the right, in total, all of this is adding to my load of my page. So all of this adds up. And what I can do is I can go in here and sort. I can sort by action order, I can sort by DAX queries, I can sort by direct query, by visual display. So if I want to figure out, okay, which visual display can I optimize, I can sort by this and I can see which takes the longest. If I want to sort by DAX queries, I can see it, and then of course I want to do the descending, we can see the one that takes the longest. So I can actually go step by step, figure out what's going on. And I think there's a few options, few good things that I can do here. So I can do copy query here. And this allows me to go into, for example, DAX Studio and paste in the query, and this is the query that's being used. And now I can actually go ahead and play with it and optimize it. Another option here is I can go in here and do export. And export saves this to a JSON file with all the information. Now the guys from DAX Studio also have this. So what I can do is load the performance data. So I can click on it, and now it actually shows me all the queries in my report. You can see all the queries that are being sent, what's the rendering time, what's the query time, how much time did it take in milliseconds, including the query. I can just double click it, and again, it's doing the same thing, but it's also showing me some statistics. What's the row count, what's the total duration, what's the rendering. So all of these things, I can go ahead and play with it. I think the most important thing here also to recognize is, even though it's showing you the query times, it is sometimes a bit lying or not showing you the real thing what's actually happening under the covers. Because in a lot of the cases, the analysis service engine also caches things. So one query can actually take longer or appear to take longer, or actually it does actually take longer because it's also loading data into the cache that other queries benefit from. So there's some caching involved, and I can show you in a second. As soon as you start optimizing some of these examples, then this definitely starts to take an effect. Like for example, if we take one of the examples, and what I usually do here is I actually like copy and paste the visuals into different pages. So in this case here, I have an example where in this model, I have a sales table, we have 200 million rows here, and I have two promotion and a product table, and I've turned on bidirectional cross-filtering. Okay? One of the common cases, and I'm actually really happy and excited about this, one of the common cases here is I've turned on bidirectional cross-filtering because I want my slicer to be filtered down to only show data where I actually have sales for. Like I don't want to have values in my slicer that doesn't have sales. In the Power BI desktop release that shipped, I think yesterday, there's now a way for you to actually filter down values in the slicer by measure. So you can say, only show me the values in the slicer where I actually have sales. And that, now you don't need to use bidirectional cross-filtering anymore. But here in this case, for example, again, what I can go ahead and do is go Performance Analyzer, start recording, refresh the visual, and now it shows me the time. Now I can show you how much this is actually cheating. Because it looks like it's actually 135 seconds, milliseconds. It was pretty fast, but I can actually go into DAX Studio and clear the cache. Now it's clearing the cache for my analysis services or my Power BI desktop file. If I now go back in and do refresh the visual, you can see it's actually taking 316 milliseconds. So you can see that's actually quite a big difference. And this is only because of the cache. So I always recommend, it's good to run the performance analyzer, and I hope we're also adding a clear cache button. I'm heavily... sorry? Okay, I already did it. Yeah, so we are talking to the devs and making sure we're clearing the cache. So we give you a button that allows you to clear the cache as well and not have to use DAX Studio. But this will definitely show you what's going on. So here it is 360 milliseconds. If I now, instead of using BiDi, I'm actually turning off BiDi, go into the no BiDi one, and again, it's 127 milliseconds. So again, I'm making sure we're going to clear the cache. I'm going to clear this one as well. So we go from 316 to 99 milliseconds. And the only thing I did here is, instead of using bidirectional cross-filtering, I wrote a measure that says, okay, calculate the sum of discount percent and turn off bidirectional cross-filtering. Because I actually don't even need it here in this scenario. So by just optimizing the model and figuring out what's going on, in this case, turning off bidirectional cross-filtering is a very good common best practice. And there are a few more. Let's go in here, because the modeling is important, right? So performance issues, what we tend to see are due to suboptimal model design. So there's a few key tips. Do you need all those 150 visuals? Yeah, we've seen 150, 300 visuals on one report page. That is causing issues. Auto date time options for Power BI. Now also you have a feature in Power BI Desktop that allows you to set, for all my models, turn off auto date time. Auto date time is great if you are a beginner user and you really want to not manage your own date and time tables. But in the general case, we say turn it off, because it's maybe not necessarily for your query performance, but also for your refresh performance.
If you care about performance, you turn it off.
Use narrow tables. So again, making sure that you get rid of keys that you don't need. They eat a lot of memory. Get rid of columns you don't need. Power BI loves star schemas. So leverage relationships and small dimensions on a table so you can filter on the dimensions, not a fact. Use special relationships like bidirectional cross-filtering sparingly, and use some of DAX best practices. So again, bidirectional cross-filtering is a great feature, but actually we don't need it anymore, except for in certain cases that you actually do need it. But for the filtering experience on the slicers, which is the most common case that people are using it for, you don't need to use it anymore. So we would say only use it when you actually have a use case, and turn it off by default on your relationships. What are some measure tuning tips? The one big one, and we have 2 minutes left, and I'll quickly show you the huge difference that variables make. So the biggest thing is, the recommendation that I make is any measure that you write, use variables, even if you don't need it. Use variables, and that gets you into a rhythm of using them. So that makes it an automatic process, because it really makes a difference. So quickly, let me show you. So here I have, again, I'm going to clear the cache, and we're going to go to my non-variable one. And here it's loading. Let me clear this one. Again, clear the cache, sorry. Refresh the visual. And this took 880 milliseconds. And this is a very simple expression. It just does, let's go in here. It just shows the margin. This is all it is. If sales is larger than 0 and cost is larger than 0, then subtract cost from sales. That's it. It's a very simple measure. But it took 800 milliseconds. If I now, again, go clear the cache, go to variable one, you see it took half the time. And the only thing I did is I changed this to use a variable. So instead of writing the full one, I'm now writing this. Variable sales, variable cost, if sales is larger than 0 and cost larger than 0, then cost minus sales. That's it. The only thing I did, and I saved half the time. So use variables wherever you can, because what it's doing here, in the previous case, it was executing every time we reference the measure. It is going to the engine and actually calculating the measure. Here, it actually calculates the measure twice, sales and cost. It puts them into the variable, and then it uses that reference values twice. So instead of actually having to go calculate it, I can reuse the value that is stored inside of the variable. So use variables wherever you can. 17 seconds left, so let me quickly go to my last few quick tips. There's a few important ones. If error, especially people who come from Excel world, use if error a lot, because that's what you need to do there. do not use it, because if error will cause huge performance issues. Instead of divide, using the operator, use the divide function. The divide function gives you a safe divide operator. If you have division by 0, usually it's if error and divide the operator together, which causes problems. So use the divide operator instead. Iterators, sum x, things like this. Do you really need it? Go use it. Again, there's a session by Marco also right now that also goes into a lot of details, for an hour long, talking about this. And then finally, if you decide to use directory, think about your DAX. So the most important thing is performance optimizer, running your reports, see what's going on, using DAX Studio to start optimizing it. So figure out where the time is being spent and how can you optimize these if you want.
Just to recap, we did like showing you the phenomena, identifying bad cases, and then what to look for in those bad cases.
Yeah, so the most important things: model data into Snowflake, no bidirectional cross-filtering, use variables, filter on dimensions, not facts, reduce the number of visuals, and a bonus would be reducing high cardinality columns to reduce the memory size and also the performance. And that's it. There's lots of further reading. You can download in the slides. You can spend days looking at this content and material. So
and the other sessions that deal with performance from this conference. You have access to the material from the other sessions in the website.
Yeah.
Then follow the shopping list.
Thank you.